Well, I'd like to welcome everyone to our first STL meeting of 2020 and 2021. Hopefully 2021 maybe is a little bit different than 2020. So I'd like to introduce, looks like online here, our executive. We have Clint, we have Sarah, we have Yutong, and we have Ralph. Yutong and Ralph, I don't see their cameras right now. If you do want to shut off your camera or whatever, all I ask is that you kind of filter in and out just so that Benji can see some of our faces. I will ask you guys to mute yourselves though, and I can control that as well if need be. Welcome, Yutong. I can see your face now. Just a few little ground rules before we start. Any of the attendees, I'm going to ask that everyone please keep yourself muted. Even just typing or dogs barking outside will interfere when someone is presenting. If you have any questions during the presentation, please feel free to type them in the chat or the Q&A function. I am looking at those and we will be collecting them for at the end of the presentation. If there's anything that Benji or anyone in the group maybe would prefer to email you about, we'll just kind of say that and I will keep a record of those and we'll make sure that either Benji or anyone else on the executive will get your question as well as your contact information to follow up with. As well as if you, at the end of this presentation, if there's any additional questions that you think of later on, definitely feel free to send an email over to the Alberta section and then we'll get back to you as soon as possible on that. I would like to thank everyone for joining us today. Our topic today is on engine oils, the GF-6 and the CK4. And our presenter is Benji. He has been, well, currently he's working with Petro-Canada, but he has definitely tons of experience. We had a trial run yesterday and I have to say Benji definitely has a lot of knowledge. I think we just kind of skimmed a bit of the surface of what he knows. So I'm definitely excited. He spent last 25 years as a lubricant technical advisor for Chevron Lubricants, Total Lubricants, and Petro-Canada Lubricants. He has also previously spent time as a grease business developer for Shell Canada, as being a department lecturer for the De La Salle University Mechanical Engineering Department. Benji developed Chevron Lubricants' largest OEM business in Asian, Middle East, African with Toyota, Honda, and Mitsubishi and Nissan. And he's trained more than 10,000 maintenance professionals over 20 years and is currently working with Canada's oil sands largest mine, the Suncor Group. So I'd like to welcome Benji and I will hand it over to you.
Thank you, Jacqueline. Let's begin with we'll be talking about updates on GF-6 and the CK4 oils. So Jacqueline covered my background, so there's no need to look at this. So we go right down to it. We have the API gasoline engine service classification. It's basically a North American for the North American market. You have of course the S designation for your spark ignition engines. The powertrain design trends. The AP later on were found out to be inadequate for engine durability. That's why some OEMs eventually had their own in-house brands. They had their own approvals for their own genuine oils. And there's also some of them had the approval system for third-party vendors. And at least one I know, as far as engine oils are concerned, they made it self-regulating exercise. The latest current right now is the API SN Plus before the GF-6 was launched last May. So you have from this listing, it's the SN Plus. And let's go a little bit further. Engine oil specifications. You have a host of different entities involved in engine oil classification and specifications. But overall, one of the most well-known would be the ILSAC, the International Lubricant Standards Approval Committee. Now, it had its roots in 1992, wherein the American Automobile Manufacturers Association involving Chrysler, Ford, GM, together with the Japanese Automobile Manufacturers Association. They formed the committee which which licensed the oil. They put up the oil LCS. Now, let's do a little history background. Why we are right now where we are. You know, U.S. car imports. It's a good slide I got from the web from Trade Risk Guarantee. U.S. car imports, they're practically nil in the 1950s. So, but population growth, urban development also of the suburbs, there came about an explosion of the demand for the vehicles for the whole continent. Now, it suffered a severe hiccup because of a war in the Middle East, starting with the 1967 Yom Kippur Desert War between Israel and a few Arab countries. I believe it was Egypt. There was also the issue about the Middle Eastern producers wanting to increase their prices. So it was an opportunity for them to shut off the tap. How would you say, to hold the West hostage? So you had 1973 oil embargo. So because of the high prices and the difficulty, well, the price of oil rose about 4 times, from about $3 per barrel then during a certain period. It ended up at around $12, which is still cheap compared to today's prices. So in 1979, faced with the growing concerns about supply, there were several significant events that happened. One of those was that the U.S. Congress passed the CAFE, the Corporate Average Fuel Economy. It was a measure of the total fleet fuel economy performance of the vehicles for each U.S. car company. Now, it's significant that also globally, Japan rose to become one of the top producers. It became number 1 in 1980, so that as much as $18 billion worth of cars were imported into the USA. Now, it's interesting at this point that politicians, they saw it was a drain in foreign currency as well as jobs in the USA. They implemented restrictions on the importation. Japan agreed finally to limit the importations into the US of about 1.6 million cars per year. However, the encouragement to put up plants of the Japanese OEMs was brought about because of these importation restrictions. That's why you have Toyota plants all over the USA, and I think at least one in here in Toronto. But it was an encouragement to bring back the manufacturing here in North America. And perhaps it's because of the increased demand for the Japanese brand in the USA. US became number 1 again, thanks also to Ford trucks and Ram by 1995. By 2001, the terrorist attacks depressed demand, and later on you had China growing globally. It became the reverse of what happened in the 80s, where the car manufacturers brought their facilities overseas for the lower labor costs, lower input costs, and again, exported them globally. That's how China became number 1 globally. 2010 saw industry in crisis, and up to, well, until 2012, you are looking at 684 car makes for sale in the USS. It's quite a difficult choice. Now, going back to the domestic car producers right then, you said you won't do it right, somebody else will. In Ralph Nader, he's an iconic activist, consumer activist. He pointed out the weaknesses in the domestic brands of the American car industry. You had the Corvair, you had the Pinto. It's an interesting shot. Keep off my rear. I'm explosive because of reported tendency to suffer explosions when you get rear-ended. And does anyone see something strange about the automatic transmission gauge. It's not what you're used to right now, because after the park, you get the reverse. The earlier designs of the 8 automatic transmission, the gauge had the reverse gear right at the end. So when you're on low, you inadvertently pull it down. You go into the rear gear, and then you might end up into an accident. So whereas compared to the Japanese brands, during the 70s, you already had products ahead of their time, and you can still see these models out in North American roads right now. The Japanese models that came out, you had the high end that were ahead of its time with interesting features, fuel injection, independent suspension, way ahead of its time, and they're still in use today. And they would have their daily commuters with innovative designs. Like, for example, did you know that the CVCC, it became the precursor for today's name of the Honda Civic, for your compound vortex combustion control. So it, in effect, the pitch of Honda then was you don't need the catalytic converter to reduce emissions. And this was sufficient enough. And as a second benefit, the fuel consumption was excellent compared to the guzzling domestic brands in North America. So let's talk about corporate fuel average economy. Right along after the the oil crisis in '73, yes, Congress enacted the corporate average fuel economy rating for the North American cars. They had the intent of decreasing energy consumption by increasing vehicle fuel economy. So how did they do it? The US car brands, they would meet yearly fleet-wide averages since 1978. You have the CAFE rates steadily going up for the coming years, and the car OEM's total fleet fuel economy rating would also go up. Now, this is interesting. You put it in today's context. Why are we having hybrids? Why are we having PHEV type of vehicles? And such exotic technologies like stop-start technology, and that grills that close to improve aerodynamics of vehicles. So it's because of the goal of reducing improving fuel economy to meet CAFE. The organizations that implemented the CAFE, it passed through the US Department of Transportation, and they mandated the National Highway Traffic and Safety Administration to set and enforce CAFE standards, whereas the EPA, the Environmental Protection Agency, EPA, would calculate the fuel economy and the greenhouse gas emission standards. Now, there was another landmark in 2010. President Obama directed the NHTSA and EPA to issue the final rules. Now, cars and light trucks from 2017 to 21 had a combined CAFE average of as much as 41 mpg. And there is another goal come 2025. It will rise as high as 54.5 mpg. Now, these rates can only be achievable through, you can't do it with the traditional internal combustion engine. You have to have technology to come in to assist the improvement of fuel economy, which we'll be discussing later on. For the FE and the greenhouse gases for medium heavy duty vehicle models, they seem to have stopped at around 2018. And there are a few interesting things happening to the EPA. Also, because of the COVID, the EPA had suspended some of the restrictions in light of the COVID, but that's another story. Let's look at the ILSAC, International Lubricants Standards and Approval Committee industry structure. It has many moving parts. the reason I showed that slide about the Japanese imports is that the question is, if you're coming out, why is your engine approval, engine classification system, why does it involve the Japanese car OEMs? Well, it's simply because they are also here in North America. When I used to deal with Chevron and when we produced the genuine oil, I found it interesting then. I didn't know the connection, but I found it interesting that the Toyota vehicles then during the 90s, they had they complied with the API service classification for their HDEOs and their PCMO. So perhaps it is because of this global relationship. Okay. The ILSAC, you have your, it's a committee that implemented the engine oil licensing and certification system. You have several known symbols that can easily be seen when you buy a jug of oil. You can see the starburst. Now, in today's context, the starburst would classify it under the GF-6A oils. We'll talk about more of this later. When you see the shield, it's for the low viscosity GF-6B oils, as you can see, and of course the donut symbol. Okay. As for the donut symbol, the service classification equivalent to the API, what is rated for would be indicated on the donut symbol. So what are the drivers of current engine designs? You have three major drivers. You need to meet fuel economy improvement requirements, and it's all aligned with the CAFE. You are looking at reduced emissions, and the performance on the performance side, you would want it to be to extend its durability and reliability. How does it go about these things? It's basically about the design of your spark ignition engines. There are several technologies right now that are in place, actually working right now, and we'll go into this one by one. You get the powertrain system, the valve trains, intake, injection, the fuel system. You have various options to go about it. One is the direct injection method. It used to be an exclusive design for diesel engines. Now it has already crossed into the spark ignition engine design. The main disadvantage is the deposits would form on one part of the combustion chamber, because that is where your injected fuel would impinge upon and burn. So the impact on oil will be soot, deposits thickening, and of course, consequently have an increase in wear. Turbocharging. Turbocharging, it used to be the exclusive enclave of exotic cars from Europe. Right now, you can get one for less than $30,000, and it might not be your iconic Japanese brand. So in short, you know what turbochargers are, but the impact on oil is you're talking about higher temperatures and pressure. So it puts an additional load on the car, on the engine oil. And when you have oil oxidizing, the degradation results in deposits and possibly increased oil viscosity, thickening, except of course if you're idling all the time, then that's fuel dilution. Then you have EGR. First time I encountered EGR was in diesel engines, but right now it is an option also for gasoline engines. You recirculate the gas back into the intake air to reduce temperatures, thereby improving your emission rates. The problem with this is that you are recirculating contaminated fluid back into your combustion chamber, so that the contamination would also increase the acidity of the oil. Again, eventual result to be your increase in deposits and oil degradation. So variable valve timing. This is information coming from JAMA, which has a strong influence with Toyota. So their name for this would be variable valve timing. But other manufacturers would have their own types of adjusting valve timing. You got the Honda method, you got even the Ford in their pickup trucks. So the problem with variable valve timing is that, again, there is an increased stress on the oil through aeration, oxidation through degradation, and eventual thickening. Because the oil would also work as a hydraulic fluid in the design. So aeration makes it, you subject the oil to additional pressures aside from the heat of and the compression in your combustion chamber. So then there is the incidence of LSPI, low speed pre-ignition. This came about when the option of turbocharging small displacement cars came about. So it's well and good. You increase the acceleration rate. Fuel economy definitely is an option to be improved upon. The problem is at low speeds, it is not the perfect seal piston rings into the combustion chamber. So eventually, oil would be find itself leaking out into your combustion chamber, and the pre-ignition, the tendency to for pre-ignition would be there at low speeds. Right now, so what happened here is when the API came up with the SN final rating, it came about in 2010, if I'm not mistaken. Towards 2018, they came out upon the request of the car manufacturers. The lubricants industry came out with the API SN+. That is to incorporate the low speed pre-ignition protection of their modern engine oils. And it's because of this turbocharging phenomena for small gasoline engines. Test method has been developed in GF-6 to prevent knocking at low speed. So problem is really you're looking at even a small, in Japan, I've seen some models, 1.3 liter engines that are turbocharged. Could you imagine the load for that small displacement being turbocharged? Okay. Upcoming trends which might affect fuel economy and emissions. There are future, it's not in the mainstream yet, but possibly available in some specialized high-end models of car manufacturers. The homogeneous charge compression ignition, HCCI. You combine the principle of spark ignition and compression ignition principles into the HCCI. So far, it's not mainstream. There are issues to be resolved, like the evenness of the air fuel mix, the possibility, of course, of spontaneous ignition. So there's knocking. Knocking is one of the problems here. But according to the designers in Nissan, HCCI, it offers the highest heat efficiency in internal combustion designs. Mazda Skyactiv X, it also is it is part of their bag of tricks, I would say. So it's quite interesting. When dealing with the Japanese companies, each and every company it's a different jungle. I found out. What most impressed me was dealing with the Nissan people and Honda. Their company made mostly and it led by engineers first and foremost. Toyota, you get a blend of businessmen as well as the engineers. But Honda and Nissan, they were the engineers. So the difference in your homogeneous uh, design engine, HECI is against it. You can see the flame front in the diesel engine would depend upon when the fuel is injected into the hot, the compressed air. So the flame front spreads out. On the petrol engine, it's the spark that ignites the combustion of the air-fuel mix. Whereas for the HECI, it seems strange. You have particular different points in the combustion chamber of your air and fuel mixture. It's fascinating. Now, this can only be achieved by melding technology. You have the mechanical design of your traditional internal combustion engines, and then you bring in IT because nothing else, sensors, computer technology can only control this seemingly challenging situation. So HECI engines, you're looking at multiple points of ignition. Sounds like an opportunity to do some engine knocking here, but somehow you get to control it to get a lean burn and to reduce your nitrogen oxide emissions. So it's an emission thing. So let's go and review your ILSAC specs. You're looking at the GF1 to GF6 right now and the corresponding API service classification. Now, it started only on the ILSAC EO LCS, started on the SH time. Before that, there was no ILSAC committee. So the present one, we're looking at GF6, but prior to that, we were looking at the GF5. The GF5 was launched in 2010 as the equivalent to the API SN. And as I said earlier, and during 2018, there was the supplementary API SN Plus classification to address your low-speed pre-ignition. On the comments, you can see the different available viscosity grades for each and every classification. So let's look at it. Let's compare the GF6 to the past from GF5 to GF3. Across the board, there is an improvement in performance on oxidation stability, detergency, fuel economy. The new tests will be for low-speed pre-ignition control and timing chain wear protection. Now, seal compatibility, emulsion retention, corrosion protection, they remain the same. There are no changes. It's interesting that we bring in the issue about timing chain wear protection. You're looking at a smaller engine that is turbocharged, and if the timing, again, here's another development in technology. It used to be that the popular low-cost alternative to timing control was through a timing belt, which could easily snap over a period of, let's say, 5 years, 100,000 kilometers. And the only high-end brands would be using a timing chain, or of course a diesel engine. Audi, for example, would use, I believe you would opted for a chain during that time until now. So the reliability is there. You don't face the problem of a snap belt while you're driving in the Rockies or towards Alaska. So, but the problem with the chain is if the wear protection is not there over time, it gets skewed up a bit. So you have a lesser efficiency in terms of the timing of the engine process, and you have reduced reliability, increased fuel consumption, increased deposit. So it is critical, this new test. Okay, so the relative quality level, we compare it to the one to its predecessor, the GF5 and the GF6. You can see again the improved performance in fuel economy, oxidation control, cleanliness. Again, the big ticket item will be its ability to protect the timing chains and to reduce the risk of low speed pre-ignition. So again, here's a slide by, I think this was by Ornite. What are the different tests? The GF5 retains the previous test. The GF6 retains the tests of the GF5. However, there have been refurbishing of the engine used due to lack of availability of parts, or there's a new engine that came along. The new test would come in for the LSPI, low speed pre-ignition, and an upgrade to the GF6 would have a new timing chain wear protection. So see the timelines at the bottom, starts from 1990 on the GF1 and right down to your GF6, which was launched. Now, getting a little more detailed on the engine tests, you have 4 existing engine tests before that have been revised for one reason or another. For perhaps it could be an engine replacement. You had parts availability issues and these types. Now, the new test would be for the fuel economy, the 6F for the 0W16 grade of your GF6B. There is an existing test that has been retained. It's the previous one. There's no change for your bearing corrosion and shear stability. It's your sequence 8. The new ones, of course, would be coming for the LSPI and the timing chain wear protection. So GF6 is not only coming in as a single entity, it's split into 2. You have the GF6A, which is an upgrade from your GF5, and for your low viscosity options, that would be your GF6B. Now let's look at it. Okay. The GF6 6A would be, as I said, just your GF5 with the improvements and the upgrade in the engines. Now, what we are looking at an overall difference in performance. You are looking at maintaining internal combustion engine cleanliness and fuel economy, because efficiency and durability, they go hand in hand. So to see your equipment down the road, keep it clean, keep it in top running condition. So that's a general thought. Comparing the GF5 and GF6A, you can see the changes in the fuel efficiency. It also has a lot to do with keeping the engine clean, protection from deposit formation, oil thickening. These are the qualities that GF6A they hang their hat on. Again, when you compare this time GF6B to your GF5, the fuel efficiency stands out. So that if you look at this slide, well, naturally, you can expect improved fuel efficiency in a GF6B oil used in an appropriate engine. The viscometrics has a lot to do with it. Instead of looking at the 5W20, you're looking at the 0W16. I have heard that BMW is testing 0W8. Oh, that is amazing. Could you imagine the tiny, even more finer clearances between the moving metal parts? Now, but you compare your GF6A against your GF6B, it's still, as I said earlier, the GF6B has the fuel economy edge. Perhaps it's the viscometrics that has something to do with it. But practically all the other protection features, they are there. And go to the next slide. Then now I find this interesting that General Motors retains their Dexos 1 classification. The Gen 2 is their latest one. So they specify this approval over the ILSAC API level. So you got a GMC SUV, you have to watch out for this. It's not enough that you use the GF6, has to comply. So the general rule for lubricants professionals, when you talk to us, we would always say, check your equipment manual, whether it be a fixed or a mobile type of equipment. So that is our first rule. Okay, as a quick reference, this can easily be seen and you can easily Google this up on the web. You can see at a glance the summary of the passenger car motor oils service classification and their development through the years. You have the API right on top, and then the classification system that runs parallel to the API would be the GF4. The GF series right up to your GF6A and GF6B at the latest. And then they have the unique Dexos 1 right now doing a generation 2 for your GM vehicles. Okay. So, I'll just catch my breath a bit. If anyone has any questions, please feel free to use your chat box. Send them over to Jacqueline. Next, we'll be jumping to your diesel engine oils. Talk about PC11. Okay, it's the new heavy-duty diesel engine oil category. It was launched in 2016 at the request of the Engine Manufacturers Association. Basically, again, we're looking at helping manufacturers meet government regulations regarding improved fuel economy performance. Again, we have the specter of CAFE always there, controlling your fleet fuel economy ratings. Again, it's driven by the EPA and NHTSA to improve emissions. So there's the emission component for diesel, because being sooty, and it's we've seen a host of interventions right now in diesel engine design, diesel particulate filters, SEA, to reduce emissions. So it started, the PC11 started in 2017 model year engines, and it was also driven by the demand for the vehicle manufacturers for improvements in oxidation control, aeration, scuffing, and shear stability. So the drive is always reduce the deposits. If you reduce the deposits, you improve the durability, you will reduce the wear likewise. So similar to the GF6, you have a split category then. When it was launched, you have the CK4 as the PC11A and the FA4 for the low viscosity option. Okay, so your PC11 has split into your PC11A, CK4. It's a more robust CJ4 engine oil, recommended by all OEMs, and again, backward compatible. Similar again to your GF6A. It deals more with the heavier viscosities, with higher high temperature, high shear numbers above 3.5 millipascals per second. It's approved also by accepted by the European car manufacturers, the ASEA group. Now you have the FA4, which is the PC11B. It's a robust API CJ4, likewise at a lower viscosity. So again, you're looking at a lower HTHS rating, lower than 3.5. We're looking at the range between 2.9 to 3.2, and it's a standalone. It it's not likely. I haven't heard backward compatibility issues so far. It's not accepted, in short. Okay. Here's a quick look on the different tests for the PCA 11 and A and B. You have existing tests that have been implemented to meet this classification. There are replacement tests and new test limits on the yellow color. So anyway, we'll just jump right out to it. So not only diesel engine oils have changed since 2016, the hardware has been constantly changing for the last, about 50 years. You're looking at downspeeding, downsizing. You're looking at the smaller footprint of your diesel engines. You're looking at the greater BMAP output, increased operating temperatures, insane injection pressures, anything to drive efficiency up. But when you do that, you also increase the temperatures, increase the pressures, and the eventual stress on the engine parts. And all the time, in the combustion chamber, the engine oil is always in contact with products of combustion in your piston rings. So it's continuously being cooked. Now imagine at even increased temperatures. Turbocharging is a normal thing right now. So could you imagine the load on your HDEOs? It's severe right now. You're looking at advanced combustion designs, variable valve timing, which used to be domain only of gasoline engines. It's right now crossed over into your diesel engines. Electronics has also come in. Stop-start operations are current options. I'm not sure if diesel engine designers also have come up with, carried the same design from gasoline engines of the selective cylinder activation, the SCA, selective cylinder activation. You have 8 cylinders, and then you'll, in the highway driving, some gasoline engine designs, they shut off some of the cylinders to improve fuel economy at highway speeds. So the significant, there seems to be another trend is perhaps a significant movement to 10W30 viscosity. The demand for fuel economy, again, because of CAFE, will drive the move to lower viscosity grades. Although going on a thinner oil, let's say from a 1540 to a 5W30, the acceptance hasn't been there yet. I haven't seen it, but in my neck of the woods, I've seen the interest from a 15W40 to 5W40, and that seems to be the next achievable step, rather than going drastic one viscosity grade drop from say 1540 to 530. So other OEM changes. Improved aerodynamics. We've seen it all the time. These are easy, quite easy. Perhaps improved tire designs to reduce the rolling resistance of on the road. Efficient transmissions and axles. That's another thing. Automation is inevitable, and you get the demand for high quality lubricants grows increasingly more and more with each new design hardware change. So the challenge is there, and that makes it an exciting industry. Give you last few slides. You see a progression of North American emission standards. I'm sure quite a few of us in the audience saw the days wherein you are looking at the diesel fuel at around 500 parts per million. That was in the 90s. And the corresponding oil then was just a CG4. It's a multi-grade, but it could handle, it had high total base number rating to handle the high sulfur levels. Okay. but right now it's gone down dramatically. You're looking at ultra low sulfur diesels at about 15 parts per million. Likewise, the emissions have gone down significantly. From an NOx of 5, you're looking at less than 0.2, and your particulate matter emissions from a 0.1 during that time, it's right down to 0.01. So it's 1/10 of what it used to be close to 30 years ago. So the emissions, the drive to reduce emissions has been there. Okay. It's an interesting slide. I think it's a Mercedes-Benz, those who are familiar with it. Yeah, 170D. Over the last 70 years, the specific output, torque, fuel economy of diesel engine cars have increased over 70 years. Even as early as the 90s, technologies like I read about Mercedes-Benz coating their piston rings with molybdenum disulfide. So that was interesting there. But right now, I'm sure there are more advanced technologies at play right now. Polymers, ceramics. You're talking of it's a host of different designs and options right now. Make it an exciting future. You combine it with sensors, artificial intelligence. Who knows what we'll be in 5 years from now? Oh, as a quick reference. Here's a quick reference again from the PQIA. You can see the progression of your diesel engine oil classification levels from the earlier years to today, right on. So the green ones would indicate the active classification, and the red ones are just the obsolete. So best to be sure, go CK4 if you don't have any FA4 type of engine that requires such an oil. So, or always refer to your manufacturer's manual to be safe. Okay, that's a quick look at lubricants terminology. You'll see it all over. As a consumer, you can see different names. Approval and licensing suggests an official test has been done, a license number has been granted, an approval letter can be referenced. So it exceeds, it's in a gray area. Perhaps a laboratory or informal field of testing has been done, but a formal official third-party entity test may not have been done. Okay, meets again, perhaps informal field testing or laboratory testing will meet and support the OEM requirements, but has no formal written OEM approval. Oh, in short, it's not licensed. Now, why would you? So, is there an intent to deceive? There is not. It's more of a business decision. The volumes for a particular engine oil, declaring that it meets and it exceeds the OEM requirements, the volume of that product line may not be sufficient to justify the expenditure for an extensive approval test. It can cost hundreds of thousands, even $1 million, I believe, close to $1 million to get such classification licenses or approvals. So they hold back and say this is an alternative for engines beyond the warranty period. Recommended for its same class, not likely to have a formal OEM approval. SFU, they're bunched in the same thing, the capability. Now, it's many reasons for this to happen, all these between it's a licensed and an unlicensed one, but it's driven basically by economics. So with that, I think I am done. How'd my time go? That's it. Thanks, Jacqueline.
Thank you, Benji, and thank you for everyone for attending. I am going to open it up to questions. There was one question that came in that Yutong answered. I'm not sure if you want to add on to it. From Tom, why is the timing chain the main focus? What's torturing the chain now? Knocking? And Yutong gave timing chain wear and tear. Do you have anything to add to that?
Oh, among other things, that's the eventual, that would be the end result. But you're looking at higher horsepower ratings, smaller clearances, turbocharging. So it is essentially a stressed environment more than ever before. So that, like they say, the timing chain, I would say, would anyone agree? Would that be a weak link in the system? Or is it the piston ring? There are weak links in the internal combustion. If you have, let's say, a valve gutter damage, so you lose your combustion pressures, you lose your power, you increase your fuel consumption. But likewise, if the timing chain is slightly altered, no matter how small, eventually it's a defect that builds upon itself and reduces efficiency. It reduces your horsepower, torque output. So I would say it's a critical thing, but I leave it to the engine designers, the OEMs, to have a final say on this. But I would say it's a critical thing. Yes. Anything else?
I do not see any other questions at this time. You verify the chat, nothing on there. Yeah, so if you have nothing else, I will let everyone go. And if you do have questions after this that come up, definitely feel free to give us a quick email or whatever, and we'll definitely pass it on to Benji or whomever should be able to answer that one for you. So, thank you, everyone.
Thank
you guys have a great day.
Thank you, Jackie.
Bye.
Clint, Yutong, Sarah.